Hello. Good evening, everybody. Good evening, everybody. I, on behalf of Green Building Solution Consultancy, I welcome all participants who have taken out their precious time to join this webinar on DesignBuilder. We, as a reseller of DesignBuilder for GCC countries, we are welcoming you all. DesignBuilder is one of the most effective and powerful tool for energy and environmental analysis of buildings, which has been integrated in a favorite interface of architects and engineers around the world. During this webinar, if any of the participants have any query or questions regarding the DesignBuilder, you can write in our chat box, and we will be answering all these questions and will be sent to you on your registered email IDs. Now, I would like to request Mr. Suleiman Al Rashid, Director GBSC, to talk about GBSC and its work in GCC countries.
Okay.
Over to you, Mr. Suleiman.
Okay, thank you, Shami, for the introduction. Thank you. Thank you all for attending this presentation. I'm just gonna take 2 minutes of your time to introduce Green Building Solution Consultancy. Our expertise in can you turn the next slide? Okay, our expertise is in complete project administration for green building certification, lead through CI existing building. We also do a complete lead for home certification that include conducting the task of green rater and resident home energy rating. DesignBuilder software that we are going to talk about today, policy design and advisory in the area of energy sustainability and efficiency, building commissioning, renewable energy consultation, and building energy performance simulation. That's all. I don't want to take more of your time. I'll leave you for the presentation. Mr. Khan, he will start giving us all the information about this presentation. Mr. Khan, will you start? Thank you.
Mr. Khan, yes, please. Mr. Khan, you are on mute. Can you unmute it, please?
Okay, sorry. Yeah,
Yes.
Can you hear me now?
Yes, please carry on.
We can hear you.
Yeah, okay, so we'll go with the presentation and it's a brief presentation showing the capabilities of DesignBuilder. And once the presentation is over, we'll switch over to the software to show you the basic interface of DesignBuilder, how to do modeling and how the inputs and outputs are integrated, so that you have a brief idea of how the things work and what is the workflow, basic workflow, and what all possibilities are there within the software. Okay, so the key features of DesignBuilder. So as you can see that it's an integrated tool, and anything regarding environmental analysis and simulation we can do on a single model or a single geometry. So we can do daylight simulation, we can do HVAC modeling, and within HVAC modeling we can go up to any details of controls. Then we can even perform natural ventilation simulation, solar PV simulation, hot water simulation. And apart from this, we have separate dedicated modules for compliance with ASHRAE 90.1 and LEED for different credit for energy, daylighting. Then for the researchers, or for those who want to optimize their design, or who are working in the research areas, they have parametric optimization and scripting option available as well. Then we can perform even CFD simulation within this, and we have LCA integration and simulation result analysis, which we do basically, which we can do within the software, and we have an external freeware software available as well for detailed analysis, post processing. Okay. So these are some of the, these are some of the outputs and the graphical things which are there in the design builder. We have discussed this thing in the previous slide as well, so we are moving ahead. So basically design builder is targeting, so if you are an architect or an engineer, or if you are working with a sustainability consultant, or suppose you are working as an energy assessor, or you are within a university doing research on built environment sustainability, built environment energy, thermal comfort, so all these things, or if you have something related to this, then design builder is the best software which is available, and you can integrate all the domains within the architecture engineering background, and within within the research part within the same interface. These are some of the outputs of you can see the 3D model that we have developed. So you can see that we can model any kind of geometry, we can model shading, we can model even solar PV on the roof, and we can model even the green roof if the design has this, or if you want to see the impact of green roof within the zone, within the or the temperature profile and the cooling loads. So we can do that even. So any kind of complex geometry, any even, so that we can perform even. Yeah. So these are some of the outputs of the models that we have prepared. Then so if you see, then within the visualization tool, we can export the outputs in the 3D outputs. So for the client presentation, so instead of showing data in a tabular form or in a data form, the design builder, what it does, it overlays the output information or the input information on the 3D geometry itself. So if you want to see what amount of solar radiation is falling onto a surface, or what is the thermal comfort of different zones, so that we can extrapolate within the 3D module, and then that information which is in output within the tabular form, it get reimposed within the 3D output form. And so it's basically very easy for the clients and for our and for the person in front to understand that what kind of output we have generated, and what is the possible impact of that on the design, on the measures that we have taken on the design. For daylighting, if you see within the design builder, so we can perform point in time daylight analysis, we can perform annual daylight analysis. Then for we have integration with the lead version 4, lead version 4.1, lead version 3. So all those lead modules are inbuilt, integrated within the design builder, and even we can generate reports from the design builder as well. And apart from that, you can see that we can generate 3D outputs for our 3D model. So we can see, okay, what kind of spatial distribution of daylighting is there within the zones and in the corridors, or any kind of space that we have designed. So for the lead, we have all the options, option 1 and 2. So point in time daylight analysis and annual metrics, both we can do within the design builder. So these are all the simulation outputs which we can perform from lead version 2 to lead version 4.1, which is the latest lead version right now. Then we have BREEAM as well, we have Green Star, and then we can perform even well credits as well for within the design builder. So this is one of the output of a simple shoebox model that we did. I'll show you how to just quickly model this thing and see if your design is complying with lead or not. So it's a very quick process, and then we can see and what needs to be done to make sure that we are complying with any of the rating authorities that we are trying to comply with. Then one of the most important feature that we face right now is that because of the integration of the design and multidisciplinary teams working across nations, we basically receive multiple format files. So for example, we may receive a Revit file which is developed by the design or the BIM team, and so design builder has a dedicated plugin which we can install within Revit, and then what that plugin will do, it will basically simplify that model and it will convert the BIM model to BEM model. So from building information modeling to building in energy modeling, and it will simplify and it will take out only that information which is required for the modeling purpose, for the environmental analysis, and then it will export that file, import that file within the design builder, and then we can post process the for working within the design builder. So for the geometry part, we don't have to, you know, spend much time in the modeling front. Similarly, if we have a PDF file, suppose we don't have a CAD file, so we can import the PDF file, we can scale it down, and then we can export the geometry. We can even import the CAD files, we can import the image files, we can import the files from Rhinoceros using GBXML format. Or so these are multiple different interfaces, which basically is these are the input interfaces which design builder supports, and then within the as an output we can export the design builder outputs into multiple software. For example, Magic CAD is there, which mostly the MEP consultants can use. Then we have one click LC analysis, which is an external tool, but which it has been integrated within the design builder so as to see what is the carbon impact, CO2 carbon footprint impact of our building. So that we can do. So possibilities are endless in a way. We can import multiple formats and we can export multiple formats and share across the design teams for possible integration and design optimization. Okay, so you can see on the left and the right. So on the left, you can see it's a Revit model, but after using the plugin for the design builder, if you can see, it's a small icon within the Revit interface. So this after using this plugin from design builder, it has converted this Revit model into a design builder model, and we don't have to do all the zoning stuff and all the modeling stuff. So it basically saves a lot of time once you are doing with the dealing with the complex models, and or so that saves a lot of time. Then HVAC modeling. So within design builder we have two options for our HVAC modeling. One is a simplified method, wherein we can just pick and choose what system we want, and with the basic controls and coefficient of performances, we can perform the annual simulation, or if you want to compare two systems. But then there is another module which is the detailed module, wherein we can model each component of the design. So we can model chillers, we can have all the set point managers, we can control humidity, we can control air temperature, or any kind of input which is there in the design. It can be modeled, and we have the pre-made modules for most of the possible systems which can be modeled, from radiant system to underfloor air distribution system to VRF and central chill water system, air source heat pump. So all those things, we don't have to model from the scratch. We can do it from the scratch, but the basic layout is available within the design builder, and we can use that as a starting point to develop our model further. Then ground source heat pump. So I'll show you how to just import those modules and use it within our model. For the ASHRAE 90.1 and LEED, so all of you who must have worked on the energy credit of LEED and ASHRAE 90.1, so you must be aware that we basically have to compare the proposed case with the ASHRAE 90.1 baseline case, and then once the two cases are compared, we have to fill the MEPC calculator, which is the minimum energy performance calculator and we basically submit it to USGBC for approval for the credit. So it's a semi-automated, or you can say it's a sort of almost an automated process within the design builder, that we only have to model the proposed building with all the controls and whatever is there, and then we just have to click on the automation of the baseline generation, and it will take into account all the protocols which are there in the ASHRAE 90.1 for geometry, and it will create a geometry based on the ASHRAE 90.1 appendix G protocols. Further to that, we can basically put in the HVAC system which basically will come as per ASHRAE 90.1 appendix G protocols. So it's a guided HVAC generation, so we can define the number of floors and what is the conditioned area, and based on that it basically guides us as to which system should be modeled, and the basic controls and all the sizing parameters are already within that module which is there within the within the design builder. So we don't have to go into controls to that much extent, because as per the ASHRAE requirement, those controls are already inbuilt within the HVAC for the baseline. Then it will automate it for the proposed. It will compare the proposed and baseline case, and then there is a mechanism to import all these outputs within the MEPC calculator. So, and that is basically the most tedious part, because it takes a lot of time to basically import inputs. So if we are doing it manually, then it takes a lot of time, but within the design builder, it's an automated process, and we can import all those inputs within the MEPC calculator and submit it. So so it's basically a very optimized workflow, wherein we can save a lot of time, lot of work hours of our team, and it's a very efficient process. We have been working on this process for so long. Then if you want to, if you so design builder has published multiple guides. So there are multiple guides within the design builder for multiple modules. So for appendix 90.1, appendix G calculate user guide is there. Then we have MEPC guide, and apart from that, there are multiple guides as well, which are available on the design builder website. You can use it and you can refer to it, so that you know what inputs are there, what is the definition, and what are the possible outputs that we can generate. So it's not a black box sort of a thing wherein we don't know what is going in and what is going out. We have a fairly good idea of what kind of inputs are going in, and certainly because design builder is the front end of the energy plus. So the back end engine of the design builder is the energy plus. So energy plus in itself has a very detailed running into thousands of pages. They have their input and output documentation, engineering documentation, which is available for free. So then we can cross refer any input parameter or output parameter from the energy plus output database as well. So in that way, it gives a lot of flexibility, and it's sort of an open source thing, that we can see what kind of input we are defining, and what impact will have on the possible design outcomes, or the energy, or the load sizing, or any kind of output that we are looking at. Yeah, so as we have discussed, we can model the PV systems, but we can even integrate it with the demand side and demand side. So, for example, if we have a PV array, so we can model the PV array, we can model the inverter efficiency, we can model the module efficiency, we can model the losses, and then we can even integrate this thing with the on the demand side. So we are optimizing the demand side on one hand, and we can optimize the supply side on the other hand as well. So it's a very powerful tool, wherein we get to know how much percent of the total demand we can offset through PV, and then those output basically comes into output reports as well. So showing what percent of our electricity we can offset from the proposed solar system. So it basically gives us a fair idea of where our buildings stand in terms of energy demand, or the need, if suppose they are doing the net zero feasibility, so that it will give us a very fair idea in the very start of the design, regarding the feasibility of all these renewable systems with respect to the demand of the building. For the natural ventilation, so we can model the natural ventilation. So within the design builder, we have two modules. One is the scheduled ventilation, and one is the calculated ventilation, natural ventilation. And so within the scheduled ventilation, we can define at which point the design builder, the windows will open, and what ACH, air changes per hour, we can predefine those things, or we can use the more detailed or more accurate method of calculated natural ventilation, wherein it will take into account the wind speed, the buoyancy, and the pressure difference outside and inside. And then we can even define controllers for temperature and humidity. So if suppose we want the windows to open at a certain temperature, once the temperature outside is very good, so windows will open. So these kind of controls we can define within the design builder, and we can integrate this natural ventilation with the room wall or any other kind of double skin facade as well that we want to model. So all these possibilities are there, and the impact of that can be seen. So on the left you can see we did an analysis on the effect of insulation on the air temperature for the top floor and the second floor. and how it affects basically how the natural ventilation temperatures vary within the building if we change the insulation level. So these kind of analysis, so the possibilities, are endless. If you want to analyze, we even within the natural ventilation mode, we can do the mixed mode simulation, wherein we can integrate the natural ventilation with the HVAC system. So that is also the possibility that we can look into. Then for the parametric analysis, so that was, so the initially right now whatever we have discussed, it was something that we are manually trying to optimize. So like for example here, if I just show you, uh, or maybe we are trying to optimize the impact of insulation on the indoor temperature. But if suppose we have multiple parameters and we want to see which is the most optimum value which we should go for the design, and we can even include the cost into it. So for example, if you see over here, what we are trying to optimize is the energy. So EUI is the object which we are trying to optimize, the parameters which are basically the variables. So total building cost, window wall ratio, glazing type, shading type. So these are the four parameters which on, and based on the multiple correlations and multiple simulations, design builder will show us which is the most optimum design combination of design, and we can choose multiple design options for the parametric optimization within design builder. So it's a very, so on the vertical axis you can see total building cost, and on this horizontal axis you can see the energy, and sort of it's showing that these parameters are in a way most optimum if you want to optimize the cost and the energy. So that these we can do, and it's fairly very simple and very intuitive, and we can perform any kind of simulation, and we can even optimize any kind of variable that we want to do. Then for those who want to go deep into the sensors and actuators, and they want to write their own script for controls, or if suppose there is something which they feel that it's a novel thing, it's not available within the module. So with the Python interface and energy plus EMS interface, we can write our own scripts, and then our system or our operation can be optimized or can be controlled using those particular scripts that we can develop ourselves. So that is also one of the possibility, and it's a very advanced tool which we can go for parametric analysis optimization, or maybe the uncertainty of sensitivity analysis. So this also we can perform. So for life cycle analysis, it's a very hot term which is right now going in. So design builder has an integration with the one click LCA tool, and whatever information we feed into the design builder, it basically goes into the one click LCA tool, and and then it automates if the design that we have proposed or the carbon footprint of it is above the baseline, or it's not there. So there are certain manual inputs, but most of the inputs, around 90%, design build the LCA tool takes from the design builder software itself. So it eases out our process of putting the things manually, and the cost, total volume and of the structure, and total volume of the spaces and the materials which are there. We can feed it into design builder once we are modeling, and then once it goes into LCA, it will automate it and show us if where do we stand in terms of carbon footprint. We can even perform the external CFD analysis. So if you want to see what is the impact of outside wind on the pressure of the building, or if you want to see what will be the impact of if you want, we are designing the pedestrian movement, and if you want to optimize the wind movement across, so that we can even do. And for the internal CFD analysis, we can even see how if there are any hotspots within the zone for the HVAC system once we are designing, so that those things we can even perform within the design builder. Then if you see, we can even perform, we can go up to hourly or sub-hourly level. And if you want to understand what is the zone temperature, what is the surface temperature, or what inputs are basically affecting our overall output income, we can do this minute analysis on multiple graphs within the design builder. Or if we want, there is a very good tool which we can export the output to, and then we can do that post processing in that tool as well. So so this is just a brief of what design builder can do in a brief. I'll just show you, I'll just switch over to the design builder software update, so to give you an introduction of how the software looks and how we can work on the software. So I'm just switching over to the software. So if you see over here, this is the working space on which we work for the geometry part, for the shading part, construction part, or the zoning. If you want to do zoning, we can define. So this is our basic working plane wherein we model HVAC system, we model all the controls or the input and output parameters. On the left, you can see it's a navigator bar wherein we can see all the building blocks. So we can navigate to surface level, we can navigate to window level, or so this is basically a tree sort of a thing wherein we can keep on exploring it, and it will take us to the as far as we want to go deep inside. And the same output, same thing basically comes into the output part as well once we are doing the simulation output analysis. So if, let's say, we want to see the what is the property of this window, or if you want to edit this window, so we can come directly to this window and we can change the parameters. And if there is something like for example, you want to change something at the global level, then we can change the parameter at the global level. So it gives basically you know a level of freedom at which point you want to make inputs changes to. So if you want to make change to ground floor or first floor or second floor or surface level or at the building level, so that is the level of freedom that design builder gives us, and it's fairly intuitive and very easy to navigate across the building. Okay, so for the working space, so I'll just show you one more thing. So for the activity, so within the activity tab, we have all the modules for how the building is operating, what are the operation schedules, what are the set points that we are looking at. So cooling set point, cooling setback temperature, then what are the internal loads, so and what are the occupancy loads, how the occupancy is operating. So we can define the schedules of throughout the year. We can define weekly schedules, hourly schedules. And if we don't want to go into the textual thing, then design builder has a 7/12 schedule wherein we can edit the schedule in this format as well. So it's a fairly graphical thing wherein we can define. So for example, if we have an occupancy of 50% or lighting at 70% at this point, so that this we can do, and it will, instead of working on text, we can work on this kind of graphical GUI, graphical modulation of schedules, and design builder offers us this as well. So it's a tabular format wherein we can adjust monthly and the weekly schedule within this interface. Then there are multiple options. For example, what kind of lighting category is there. So this is basically needed for the ASHRAE baseline generation, but for now you can see all the internal loads which goes into the building, from occupants to internal gains to lighting, all those things and their operation can be defined over here. And for example, suppose we have a different schedule in zone 1, so we can go to zone 1 and then we can override the default. And let's say I change this thing, so let's say it's a sports lecture occupancy, so then it will change to sports lecture, and this zone will basically behave as per this definition. And the zone 1, which is there in the block 2, it will behave as per the residential residential definition. So that we can do. For construction, design builder offers us an option to just see in one single pane what kind of construction which we have used. So there is an inbuilt assembly within this which we can use. So if I can just show you, so below grade walls, ceilings, floors, and all these things are built within are basically within the design builder library data. And this is the ASHRAE baseline data which is there. So we can use the ASHRAE baseline data as well, and once we automate for the baseline, it will automatically take it based on the climate zone. So suppose, let's say, if you want to change the wall assembly, so once we click on edit, we can see how many number of layers are there in our wall. We can change it, we can edit it, we can reduce it. And even we can change the properties of the conductivity, specificity, density, or surface properties, and all those things we can do it over here, for because these texture and all these reflectance, emissivity, all these comes into account once we are doing the daylighting simulation as well. And we can even perform the condensation analysis for the layer that we are doing. So it's not a hygrothermal thing, but it's a basic, it gives us a basic understanding of how the condensation analysis will work. Even we can add cost of each assembly, so that can even go once we are trying to optimize the cost within the design, so within the design builder. So this is a level of modularity that we have. So we can perform, we can change any kind of layer, we can change flat roof, we can change wall, then we can see what kind of infiltration will come into our building, so we can just change into it. So for the openings part, then we can similarly we can go to the reference glazing. So we have n number of glazings from ASHRAE baseline database, from double glazing database, skylights. So double glazing, we have multiple options from low E glass. So if you don't want to make it a custom glass, we can just use a specific glass which we think is closest to our number, and then we can just apply it over here, and it will come over here. And if we want to manually change it, then we can define the SHGC light transmission and U value in a very simple way, and we can add the cost anyways. And similarly for the lighting, we can define lighting power density. We can define the lighting controls. What kind of lighting controls are there? If it's a stepped control or if it's a linear control. So that kind of thing we can control. We can even define the inputs for the clear control with what kind of then what is the area which is being governed by the lighting sensors. So that we can add within the lighting module. So for the HVAC, we have even so this HVAC tab basically gives us an input into the basic. So I just told you that there are two modules within the design builder for HVAC modeling. So these are all the modules which are there in the for the simple HVAC modeling. And right now, if you see over here, it has been greened out because I am right now into the detailed HVAC module. That's why it's overriding the basic HVAC module. And yeah, so for the generation, we can electric load center I've shown you, but for now I'll just not go into it. I'll just show you how the HVAC module works. So once we come over here, you can see that it's a VRF outdoor unit which has been connected to the indoor unit of the 3 zones. So we have 3 zones, zone 1 for each block. And hello. And if we want, we can load the HVAC system, and we have the pre-built modules. If I can zoom in into it. So if you see, we have air source heat pump, we have VRF, we have unitary air to air heat pump, so solar assisted absorption chiller. So any kind of possible system that we want, it's already there within the design builder. We can just load that module, and we can import it into design builder, and we can basically model it. And if you want to do it in a custom manner, we can change the controls. So if you see over here, it's an AHU, then this is set point manager, then these are all the fans. So and if you want to go, we can change any kind of input we want. So suppose we want to change the cooling COP, so we can override the cooling COP. Or if you want to have a typical, so for example, we want to have a LGVRF curves, so we can have LGVRF curves. Or even if you don't have any module, if you want to have a custom performance curve, or if you want a custom VRF system, then we can even make our own curves within the design builder, and we can import it into this assembly. So it gives us a very detailed modularity of what we can do in terms of performance curves, in terms of efficiency and controls, so as to make sure that our system is mimicking the system which has been designed by the HVAC engineer. So we are on a way, our outputs are fairly close to what is expected in the real life scenario. So if I just go over here, so on the top we have all the input parameters, and on the down we have all the output parameters. Okay, so let me just go to daylighting part first and just show you how we can So I have selected lead version for option 2 for now, and I'll just click OK. So it will just run a basic run, and it will give us an option that if the project is failing or if it's passing as per the lead version for option 2 or not. It will give a basic output report over here. Similarly, if we don't want a report, we want to see the map. So it will show us the detailed map with the with all the lux level or the daylight factor level for each grid. So we can define this grid. Size of the grid 1 by 1 meter, 1 by 2 meter, whatever you want, and we can export this data out as well for post processing in Excel or any other software that you want. So it gives us a very fair idea of if we are able to comply with the any other. So we have shown you in the presentation that we have lead version 2, version 3. So any kind of software that green building rating system that we want, we can just select this, and it will basically run the simulation and see if it's complying with the requirements of the code or not. Similarly, for the annual simulation, I'm not updating it right now because annual simulation takes slight bit of time. It will take around half a minute, so we'll have to wait for it. So I am not going in that direction, but the process is same. We can it for the point in time analysis, it will go give us the illuminance map, and in the annual daylighting, we can similarly select all the options for lead and BREEAM, and then we can say if you want to see SD or ASC, annual sunlight exposure or spatial daylight or autonomy. So any kind of output that we are looking at, we can see it and we can export it, and we can see what we can then again come back to the layout, change the glass, change the VLT of the glass, then again go to the daylighting and again perform the simulation and see if we are able to comply with lead version 2 option credit or not. So in this way, we will be able to make sure that our design does not get stuck at the later stages of the design, but we are basically able to meet the criteria of the code or any other local authority, whatever regulations are there. Similarly, for the cooling design, if for the HVAC engineer, if you want to see what is the sizing of the system or what are the space loads which are there, so we can just click on the cooling sizing and we can click on update, and based on the HA heat balance method, it will calculate the heat load, and it will give us a summary of what is the total design capacity of the system. And for the design day, we can define if we want to size it on multiple design day or the peak design day. So that is the possibility and flexibility that we can do. And then we can go, so if you see at the zone level, what is the air temperature, what is the outside temperature, then what is the total cooling load, what is and how the heat balance is working out. So if suppose we go to the comfort, it will show us all the parameters of the comfort. If we go to the internal gains, it will show us how the internal gains and the heat balance is working out. And if we go to the fabric and ventilation, it will show us how the heat gain is coming through the fabric and ventilation, through external ventilation and infiltration. Okay, so similarly we can do the heating design part as well. And for the visualize tab, it's a very good tool. Basically it will give us an idea of, so if we click on the rendered view, so we can show sun path diagram. So it will give us a sun path around our building, and we can size it, we can increase the size of the curve of the arc if you want. Then once we click on the show shadows, so if suppose we want to see what will be the penetration of the sunlight within our building at this particular point of time, so we can change the time. For example, if I want to see at suppose 2 p.m. and then 15th of suppose December or October, then we will have an idea of if the daylight will go in or not. Or if you want to see within the peak summer month, if the what will be the impact of penetration of daylight. So if we want, now you can see that at 2 p.m. and on 15 July the sunlight is somehow going into the space. That means we'll have heat gains, or we can still have glares because there is no shading right now. So we can add a shading, and I'll just show you how to do it. We can go to the openings tab. It's a very simple thing. Click on local shading, click 1 meter overhang, and then we have 1 meter overhang across all the windows. We can click on visualize, and now if you see on 15 July to 2 p.m. we don't have the sunlight going within the space. Okay, so based on this, we can even design the daylighting, also sorry, the shading devices of our building as well. that on the peak summer day or the peak winter day, when we want to cut the sun or we want to allow the sun within the space, we can size our vertical and horizontal shifting devices based on that. Okay, and if you want to see the rendered part with respect to the construction, or if you want to zoom into a particular thing, or suppose we want to show it in a section manner, so we can show it to the client that whatever has been modeled in this section, or we can reframe the section to the vertical axis, so we can change the axis, we can look it from the top as well. So and so these are how we can render it, we can make sections out of it, and we can see how the building looks in terms of geometry. So whatever we have modeled, we can present it to the client in a more presentable manner, and that will basically validate things that we have been doing within the software. Now I am coming to the simulation part. So we have done the cooling design, we did the visualize, we did the daylighting, and how the reports comes out. Once we go to the simulation, we can, so for now we have defined all the inputs for internal gains, we have defined the windows, we have defined the constructions, everything has been defined, and all those most of the things were predefined and the defaults, but and the HVAC system has been defined. So we'll click on the update data, and we'll select what do we want. If you want annual simulation, we can click on annual. We can, if you want us to see how the building is behaving during summer typical week, we can, or we can manually override which month, from which month to which month we want to run the simulation. And over here we can say select if you want the outputs in daily format, hourly format, sub hourly format, and then even we can choose which kind of outputs do we want. So if we are doing adaptive comfort, thermal comfort from SRS standard 55, we can click on this. So those outputs will come out. And if you select on store surface output, then the surface outputs will come out in the output tab. So it gives us the possibility of what kind of outputs do we want, and how much heavy do we want our file to be. Similarly, for the annual reports, we can select what kind of output reports we want it annually, monthly, and then we can even go to the miscellaneous output of what kind of HVAC temperatures are there, what is the amount of flow, chill water flow, what is the amount of heat exchange which is taking place. So all these things we can select, we can choose based on the kind of project we are working and the kind of output do we want. Then we have a simulation manager as well, wherein we can manage all the simulation that we are doing. So once we click on OK, it will generate the thing, and it will perform on the simulation over here. So you can see on this thing, the building name is here, then the file name is there, what time, how much time it took to run the simulation. So from here, what we can do is, so we did an hourly simulation. If you click on this, we can load the result into design builder. And if we click on this, we can export this result into an external tool, which is a basically design builder result viewer, and it's free of cost available. We can import any ESO file within this. So if you see within the summary, it will give us the summary of what is the weather file that we have used, then what is the annual bill, what is the annual sorry an energy consumption of the building within the given time frame, what is the building area. So all the summary which we have selected over there, then what is the window wall ratio, what is the latitude longitude of the building, all the input that we have given over there will come in a summary form in the report format over here. So all the construction details, and if we want more details, then we can even go to more details. So what is the sizing of the fan, what is the flow per fan, so all these things will come over here. And even if we go, and if you are basically looking into lead, so it will give us the summary for the lead as well. So if you are specifically looking for lead output, it will give us the output in terms of the lead output summary we want. Okay, and so this is this thing. But since we did the hourly simulation, if you want to see the how the air temperature is modulating across the air, we can click on hourly, and then it will give us all the outputs which are there in this format. Okay, and suppose if I want to see what is the zone air temperature at a particular point of time, so we can click on zone mean air temperature for block zone 1, and it will show us the temperature. So on the vertical axis, you can see it's a temperature, and on this thing, you can see these are the for July 3rd to July 9th. So we didn't run the annual simulation, we run the simulation for these 7 days only. So if you can see, if let me just zoom in over here. So once the building is occupied from 9, to 6, that's the temperature is being maintained as 26, and over here the temperature is being maintained at 32. So if you remember, if I just go back to the activity tab of the building, we have defined the cooling set point as 26 and cooling setback as 32. So this is the same temperature which we have got in output, since because the controls and the system sizing is correct. So that means we are able, the system that we have designed is able to meet the temperature that we are looking at. Okay. Similarly, if we basically want to see what is the overall electrical profile of the building, okay, so then we can close this thing, we can remove this chart, and we can, so we can even say what is the zone operative temperature. So there is a difference between air temperature and operative temperature of the zone. It's an average of average of air temperature and mean radiant temperature. So that we can see what is the impact of insulation. So what is the mean radiant temperature within the zone. So if you see, it's fairly higher than what the air temperature was, because system is controlling thermostat is on the air only, but over here the surface temperature is still going high. So if you are doing thermal comfort analysis, we can see, okay, if even if the air temperature is this much, maybe the occupants will not be comfortable because the surface temperature is very high. So these kind of we can even plot the relative humidity within the space. Okay, so these are different outputs which we can even plot what is the part load ratio on which the system is running. So the possibilities, are innumerable. We can, it depends on what we want, and what we are designing, what kind of system we are optimizing. So we can take this output daily as well, we can take it monthly or throughout the run period or hourly. And if I just show you, if you don't want an external software, if you want to just use the outputs, you want to see the outputs in the design builder, you can just click, sorry, I just ran too fast. So click on here, and if you go to this to load results into design builder, all the outputs that you are looking over there, basically they have come into design builder. So from here, it gives us the flexibility that we can choose which zone or which level you want to see the outputs at. So if you want to see the wall outputs, so there are no wall outputs because I have unchecked the surface output, so there are no surface output right now, but the outputs are available till zone level also only. So at zone level we have, comfort outputs, internal gains, whatever was there. So all these outputs are within the, we can use this navigation bar, and we can select if you want to see the output at building level or zone level, whatever you want. Okay, and then we can again go to detail mode, and we can add more outputs if you want, and if it's not coming in the default output tray, so that when we can perform. So in this way, it's one of the few software wherein you can perform the HVAC simulation, daylighting, cooling sizing, and all the controls for HVAC. Then you can perform costing, solar PV you can model, and we can even perform the parametric analysis. So this is, one of the very few software wherein all these things can be performed. I think with this, I rest my case for now. This is the brief summary of what we can do. So the software is very huge, and the outputs are very huge. So let me just show you one more thing. So if we click on this thing, generate baseline building, so it will say ASHRAE 90.1 standard applies to, and so it basically gives us a pop-up if there is something which is not going as per this thing. And once we click on next, it will generate the baseline building. So we don't have to apply the construction, we don't have to apply the baseline parameters. It will basically be as per the ASHRAE protocols, it will give us the baseline building. And if you see over here in the construction part, all the ASHRAE baseline constructions have been applied within the baseline building. So we can then model the HVAC system, and our work got reduced to half in a way. I think Shami, this is from my side for now, because the time is now running out again. And the modules are still left, but I think this is more than enough for, if we can have some queries, we can just answer.
Sure. If somebody has any query in this regard, what we have presented right now, they can ask by unmuting themselves.
Any query related to HVAC or daylighting or anything related to the possibility of geometry construction creation or editing of properties, anything if you want to ask, or if there is something.
Hello, can I ask about the energy? Can we also have some data about energy usage, energy savings?
Mm-hmm.
For energy saving, is there like some data that we can get from the software?
Yeah, so if I show you this output, so within the summary, if you see, this is the total energy consumption which is for the 1 week. Okay, and the split of this is that the cooling consumption is this much, lighting is this much, and equipment is this much. Okay, so this split we can get within the different end uses, or if you want a detailed kilowatt output of this, we can go to lead summary, and then here it will show us what is the peak kilowatt hour and what is the peak electricity demand for that particular end use. So this is how we can, and if you want to compare it with another suppose ECM, then we can change that particular ECM and then we can rerun it and to see what is the impact of that thing in with on the cooling demand or lighting demand or whatever end use that we are trying to modulate or optimize.
Thank you.
Yeah. Okay.
I think,
Assalamu alaikum.
yeah, please.
Yeah, I have a question. First, thank you for this lecture. Is it possible to simulate the renewable energy for
Mhm.
building, such as solar panels or wind
Yeah,
turbines?
so I've shown you over here in the presentation as well that we can define even the PV array, we can define the electric load centers, and we can go to the parameters of the inverter, what kind of inverter is there, what is the losses. So all those things we can model within the design builder, and we can even integrate the demand side and the supply side. So that can be done, and we can manually model the PV array as well. So if I show you this, if you can see over here, so these are the PV modules which the modeler has done. So we can take the impact of shading as well. So it basically it's a opaque object, and it's the construction is basically the same as the PV module, and it gives the total impact in terms of the shading on the roof as well, and we can have the generation output as well. So if you see the photovoltaic power in the output, it shows us what is the total generation from the photovoltaic or the wind, or what percent is it for the total energy end use.
But it should be specified. It's not automated by the
No,
software
we have
itself.
to specify the PV module that we are modeling. So and we have to define all the properties of the system that we want to have. So this is basically that then we have to edit this thing, and then we can define what kind of inverter is there, what are losses over here, and uh, then photovoltaic modules or BIPV or glazing with BIPV. So these are the input parameters that we have to define first, and based on that the output will come based on the azimuth angle and the orientation that we have defined in the geometry part. So over here in the layout we will define the solar PV modules, what is the angle, what is the orientation and tilt, and the properties of that we will define in the generation tab for the system and for the modules. And within the output it will give us the within over here in this simulation, if you go to summary, it will give us the output if we or maybe over here. So this is the output. It will give us an output within this thing, within this report, that what is the generation we are having.
Great, thank you.
Okay.
If anybody has any query in regard, they can ask right now, or they can mail it to us on our email ID that we have entered in the chat box as contact@gbsc.sa. We will reply to those to your questions and queries that you have. So I think now we are done with all the queries. We don't have any queries right now in our chat box. So thank you all for joining this session. And hopefully in future, if we have some these sorts of webinars in regard of Design Builder, we will surely mail to you all who have participated right now. Thank you for joining. Thank you. Thanks a lot.